So let's try to determine the translation of line L, 3x minus 4y equals 12, via a vector of negative 2 and 5. In the previous video, we're able to establish the idea of identifying the process of translating a certain line to somewhere where it be pushed using the vector negative 2 and then 5. Now for this instance, take note that a line L here is composed of infinitely many points. So we are going to treat those points as arbitrary values, okay? But we are still going to use the idea of summing up the quantities of your first components of your points and your vector and the second components as well. But for a line, let's do it in this manner. We are given with a vector of 2, that's negative 2 and then 5, right? So our equation is actually identified as 3x minus 4y is equal to 12. So we need to come up with another equation of a line form, which would actually be representing the translation of L along the vector v. In order for us to do that, let's try to graph first. Okay, for this instance, let's graph this line on this Cartesian plane, and then later on we can see, or we can also need to plot also the translation and see if they are actually translations of the other or something is pushed by the other using the vector. Take out the vector here is at negative 2 and 5. If we're going to plot that solely on the Cartesian plane, it moves towards second quadrant because x is negative and y is positive. So hopefully our translated line would also look like the original line being pushed into the direction of the second quadrant. Not necessarily the second quadrant, but it looks like it's being pushed to the second quadrant when we talk about picking a certain origin as a point on that line. Anyway, let's graph that. So for our x-intercept first, okay, let y be equal to 0. So you have your 3x minus 0 is equal to 12. 3x is 12. X is 4, so your x-intercept is 4, 0. For your y-intercept, let x be equal to 0. So you have 0 minus 4y is 12. Minus 4y is 12. So y is negative 3. So the y-intercept is at 0 and negative 3. Plotting that in our Cartesian plane, we have this line, original line, 4. Again, assuming that each grid here is per 1. So 4 and 0 and negative 3. Connecting them with a certain line, hopefully I could draw a line representing them fully. Oh, I can't. Let me do it again. Because it should pass through the 2 points with ease. Okay. Assuming that this is really accurate, this is your line L. Okay. Line L represented by 3x minus 4y is equal to 12. Okay? Now, if it would follow that our translation is by a vector of negative 2 and 5, which is a direction on the second quadrant, it should actually push this to that direction. So supposedly, if just by prediction, our translated line must somewhere here, where this line is being pushed to that direction. But still, we are to verify that using these next few important steps. The first step is we need to identify the representation for all points, because here we can actually have all points x and y. So for the translated line, okay, that's L prime, we also need the points x prime and y prime for all points in that direction. Now, considering that the concept of points are being revisited, take note that for a translation, for a certain point P, let's say this point P, on using the vector, we are going to add up, okay, the components of your vector and your points, right? But since our points are actually arbitrary here because we have a lot of points, but our vectors are very specific, we can draw it in this manner. This being equal to that, our x prime and y prime is composed of x sub 1 plus v sub 1 and x sub 2 plus v sub 2. In short, the points are, or the coordinates, or the ordinate x prime is just x sub 1 plus v sub 1, and for your y prime is actually x sub 2. Okay, I'm not using x sub 2, rather, pardon, because I'm using p, x, and y, so I'm going to use x and y here. Pardon, I am using this, so this should be x and y. X and y. So this would mean this is actually x. But just for the general components, that's why I used here y and x sub 1 and y sub 1. So you have y plus v sub 2. Take note that our vector v sub 1 and v sub 2 is identified earlier as negative 2 and 5. So the general form for this is, again, our goal is to come up with the equation of a line. So our x prime is x plus your v sub 1, which is negative 2, or you can simply write it x minus 2. And for your y prime, you will have here y plus 5. Okay? Our goal is to come up with an equation containing the primes. So let's pattern it to the given equation here. This is our given equation. Our given equation is 3x minus 4y equals 12. So for this, we can solve x and y to be substituted here. Okay? So for our x prime, being x minus 2, so our x is x prime minus 2. Plus 2, as we move that on the other side. For our y prime, being y plus 5, our y is y prime minus 5. Right? So substituting that here, our L prime now will be 3 times your x, which is x prime plus 2, minus 4 times your y is y prime minus 5, is equal to 12. Okay, that would mean you will have here the form, okay, 3x prime plus 6 minus 4y prime plus 20 is equal to 12, which would give us 3x prime minus 4y prime plus 26 is equal to 12. This would mean our translated line along vector negative 2 and 5 is 3x prime minus 4y prime equal to negative 14. This is the given, this is now the identified translated line. Take note, its slope is the same as the slope of the original given. Hence, we are sure that the translated line is also parallel to the graph here. So let's plot this just to be sure of. So for our x-intercept, okay, so let y be equal to 0. So 3x prime is equal to, that's of course minus 0 is equal to negative 14. So our 3x prime is negative 14. X prime is negative 14 thirds. This is actually negative 14 thirds and 0. Okay? For our y-intercept, let me move it here because I might not have enough space. So let x be equal to 0. So you have 0 minus 4y prime is negative 14. Minus 4y prime is negative 14. Y prime is negative 14 fourths, or simply negative 7 halves, right? So its y-intercept is at 0 and negative 7 halves. So plotting them on our Cartesian plane, because 2 points determine a line. Okay? So negative 14 thirds is negative 4 and 67. So you have here 3 and 4, somewhere near 5. Okay? Somewhere near 5. And 0, 7 halves. 7 halves is actually negative, what was that? Negative 3.5, sorry. Negative 3, was it negative? Sorry, I am very sorry. This becomes positive rather, because that's negative and negative, right? So this will become positive 14 fourths or 7 halves. So that's actually positive 7 halves, because I need my lines to be parallel. So 1, 2, 3.5 somewhere here, connecting them with a line. Okay, so hopefully it would also connect here, somewhere like that. Okay, I don't know if it's parallel. Let's do it again. 67. Yeah. So last try. Okay. All right, so more or less it's now parallel. Okay. This would be our L prime, okay, which is indicated by this equation, this one here. And as you can see, it is really being pushed into that direction, okay, because the you can also check for the what they call this one, the translation of every specific point. If you're going to pick the coordinates here, so it's actually being pushed into that direction as well. On the second quadrant, if it's our vector is solely placed on the Cartesian plane. So this is the translation of this given line by a vector v. Supposedly, we are going to come up with what do you call this one? Um, broken lines. Let me use broken lines. Broken lines. Okay. So let me erase the line that I have drawn earlier. Sorry for that. So assuming that my broken lines are actually straight. So that's the translation for every point in this line L. Okay? So we'll have more examples as of this as we move forward to this topic. Thank you very much for watching.